This is continuation of the review questions on matrices and determinants. So this is question 28. 27 was the last we did. So here we have a matrix A given to us. The question says compute A inverse. So the first part of the question is to find A inverse. We are just trying to find out A inverse. And then you have a verification part as well. So when they say show that 2A inverse is equal to 9I minus A, we'll work out the left-hand side. Then you will do the right-hand side and show that both are equal. So two parts. The first part, to find out A inverse. So let's try to recollect the formula for A inverse. A inverse is 1 over determinant A into adjoint of A. So that's the formula for A inverse. So we are trying to find out A inverse. For that, we need two things. One is determinant A and the other is the adjoint of A. So let's find out determinant A first. So determinant A is determinant 2 minus 3 minus 4 and 7. And to find the determinant, I need to do AD minus BC, like that, cross multiply. The diagonal elements you multiply first. And so when I multiply, I get 14. And it's always subtraction in between. Then you multiply the other two. That is these two. Minus 4 into minus 3 is positive 12. So that's going to give me 2. That's determinant A. Now we need adjoint of A, and adjoint of A for a 2 by 2, we have a shortcut. If it is 3 by 3, you need to calculate all the cofactors, write the cofactor matrix, and inverse will be the transpose of the cofactor matrix. So here we have a shortcut for a 2 by 2. So for a 2 by 2 matrix, what we do is we interchange the diagonal elements. When you look at A, pick up the diagonal elements and interchange their positions. These elements are to be interchanged. 2 and 7 will appear here as 7 and 2. And not finish, the remaining elements, those two, you will make them opposite signs. If it is positive, it becomes negative. If it is negative, it becomes positive. So here it becomes positive 4 and positive 3. So that's adjoint of A. So now I can write my A inverse. A inverse is equal to 1 by determinant A into adjoint of A. So 1 by determinant A, which is 2, 1 by 2, into adjoint of A is 7, 3, 4, and 2. You can take half inside if you wish. So that's going to be 7 by 2, 3 by 2, 2, and 1. You could also write it in decimal form, 3.5, 1.5, 2, and 1. Okay, so that's my A inverse. So I answered the first part of the question. Now the second part of the question is a verification question. So you need to do both the LHS and the RHS. So this is for the second part. I'm going to copy the LHS, get the answer. Left hand side is 2 times A inverse. Basically the half outside of this gets cancelled. The half here will get cancelled when I say 2 times A inverse. So if you understand that, so basically what is happening is I take 2 and multiply here. So 2 and half will cancel off. So I'll have just 7, 3, 4, 2. Or 2 times this and multiply every single term by 2. So 2 times A inverse will be 7 by 2 into 2. 7, 3 by 2 into 2 is 3. 2 into 2 is 4 and 1 into 2 is 2. So that is 2 times A inverse. Now I need to find out 9I minus A. That's the RHS. So the RHS is 9I minus A. 9I means 9 times I. They didn't tell you I is of what order, but that's common sense. Your A is of order 2, 2 by 2. So this has to be a 2 by 2 square matrix. 2 by 2 identity matrix. So it's 1, 0, 0, 1 minus A. A is 2 minus 3 minus 4 and 7. Try to work this out. So that's going to be 9009 minus 2 minus 3 minus 4 and 7. So when you subtract it, you will get 2. 9 minus 2 is 7. 0 minus minus 3 is 3. That's going to be 4. And that's going to be 2. And then we can see that both LHS and RHS are equal. So we say LHS is equal to RHS verified. Okay. Let's move on. The next question, question number 29. If you want to pause the video and do that yourself, please go ahead and do it. Okay. So pause the video whenever you require, do it yourself, and then check only the final answer. Okay. So here the question is to find out A transpose. That's A transpose, the whole inverse. So you need to find out what is A transpose, then find its inverse. Yeah. So find what is A transpose, and you know how to find out inverse of a matrix. Find the inverse of that new matrix. Yeah, that's all what you need to do. Or if you know this result like A transpose and inverse are interchangeable operations. It's good to know. So, which means I could rewrite it as A inverse the whole transpose. They are interchangeable operations. Transpose and inverse are interchangeable operations. So there are two approaches in this. Just find out A transpose, then find its inverse. Or find the inverse of A first and then take its transpose. Both will give you the same answer. It's up to you to decide. I'm going to find A inverse because it's easier to talk about A rather than A transpose. So I'm going to find out determinant A. So what I'm going to try here is find A inverse first, then take its transpose, which will be same as the original question, A transpose the whole inverse. So since I am looking for A inverse, I need determinant A. Determinant A is determinant 1 minus 2, 3, 0 minus 1, 4, minus 2, 2 and 1. Then I start expanding. So 1 into cross multiply. So you get minus 1 minus 8 minus. It's always subtraction. Yeah. So the position sign is negative. Then the element there is negative 2 into its minor. So negative 2 is the element. I delete the row and the column it contains, cross multiply. So 0 into 1 is 0 minus minus 8. So 0 minus minus 8 plus 3 into its minor. 3 is the element. Delete the row and the column it contains, cross multiply. You'll get 0 minus 2. 0 minus 2. So that's going to be minus 9. So that's going to be plus 2 into 8 minus 6. So that's going to be 16 minus 15, which is 1. So determinant A is 1. I get determinant A as 1. So I'm going to now find out the cofactors of A. Cofactors of A. So cofactors, when I find, I write it as A11 with plus, then A12. A12 will be minus, then A13 will be plus. A21 will be minus, alternate plus minus. So A22 will be plus, A23 will be minus, A31 will be plus, A32 will be minus, and A33 will be plus. So now I calculate the elements. First row, basically, I already have it, like these ones, yeah. So I'm going to just directly write it, minus 1 minus 8, which is going to be minus 9. The next one is, it's minus, it's 0 minus minus 8. 0 minus minus 8, which is going to be finally minus 8. The next is 0 minus 2, which is minus 2. A21, that's the element. So I delete the row and the column it belongs to, then cross multiply. Minus 2 into 1 is minus 2, minus 6. Look at that again. That's the element A21. Delete the row and the column it belongs to. The rest of the 4 elements form a minor. Evaluate it. It will be minus 2 into 1, minus 2, minus 6. So this is going to be minus 2, minus 6, which is going to be 8 here. Then A22. Okay, so I'm back here. Okay. So A22, that's A22. So delete the row and the column it contains. Cross multiply the rest of it. 1 into 1 is 1 minus minus 6. 1 minus minus 6, that's 7. Then A23, that's the element. So delete the row and the column it contains. Cross multiply. 1 into 2 is 2. 2 minus 4. So that's going to be 2 minus 4, which will be 2 there. And when you come to A31, that's the element A31. Delete the row and the column it contains. Cross multiply. That's minus 8 minus minus 3. Minus 8 minus minus 3, which is negative 5. And A32, that's the element. So delete the row and the column it contains. Cross multiply 4 minus 0. So that's 4 minus 0, which will be minus 4. And for the last element, A33, delete the row and the column it contains. Cross multiply minus 1 minus 0. Minus 1 minus 0. So I have the cofactor matrix, and so I can write A inverse now. A inverse is 1 by determinant A into adjoint of A, which is 1 by determinant A is 1 into adjoint of A. Now, what's the difference between cofactor and adjoint? We found the cofactor matrix. Adjoint is the transpose of the cofactor. So I read the first row but copy as the first column. That's transpose. So I look at the first row but copy as the first column. Minus 9, minus 8, minus 2. So I copied the first row but I read the first row, wrote it as the first column. Then I will look at the second row but copy as the second column. So that's going to be 8, 7, and 2. Then you look at the third row, but copy as the third column. So that will be negative 5, negative 4, and negative 1. So that's A inverse. But your question is not to find actually A inverse. Your question is to find out A inverse the whole transpose. They didn't say A inverse the whole transpose, but that's the equivalent form we know. So A inverse the whole transpose. Take the transpose of this. Minus 9, 8, minus 5, minus 8, 7, minus 4, negative 2, 2, and negative 1. This is A inverse the whole transpose, but that is actually same as A transpose the whole inverse. Because as we discussed, these two operations, inverse and transpose, are invertible. So I can say A inverse the whole transpose is the same as A transpose the whole inverse. Actual question was to find out A transpose the whole inverse. So here we have the answer. A transpose the whole inverse. Yeah. Okay. Question 30. Find the adjoint of the matrix A and hence show that A into adjoint of A is equal to determinant A times I3. A times adjoint of A is determinant A into I is a result which you need to actually know. But here the question is to verify that the result itself. So we are just trying to, we already knew this result. In the previous video, we actually used this result. A times adjoint of A is determinant A times I3. You can get 1 mark questions based on it. Yeah. So they will give you an A and ask you to find out determinant A. Yes, determinant A they will give you and ask you to find order, of course. What is A into adjoint of A? So we'll directly say determinant A times I3. That's it. Okay. But here the question is different. Here the question is to verify this result itself. So I need to work on the LHS. I need to do the RHS and show that both are equal. The trouble with LHS is I need adjoint of A. Adjoint of A is the transpose of the cofactor. So it's pretty long. I need to find out the all the cofactors, then take the transpose of it to get the adjoint of A. Also for the right hand side, I need determinant A. So everything I need determinant A, I need all the cofactors to be calculated. Then I will copy the LHS and work out that. Then I copy the RHS and work out that and show that both are equal. So I'm going to first find out determinant A. So determinant A is determinant -1, -2, -2, 2, 1, -2, 2, -2, and 1. Then I start expanding. So when I expand it, it's just finding the determinant. -1 into the first element into its minor. What's the minor of -1? Delete the row and the column it contains. Cross multiply. 1 minus 4. 1 minus 4 minus -2 into its minor. Minor of -2. Delete the row and the column it contains. Cross multiply. 2 minus -4. 2 minus -4 plus the next element is also -2 into its minor is delete the row and the column it contains. Cross multiply. -4 minus 2. -4 minus 2. So that's going to be -1 into -3 plus 2 into 6 minus 2 into -6. So that's going to be 3 plus 12 plus 12. It is 27 there. So that's determinant A. Now I need all the cofactors to be calculated for adjoint. So I'm going to calculate all the cofactors. A11, then I write A12, then I write A13. So that's going to be plus of, cross multiply and find it. So for the first element, delete the row and the column it contains. Cross multiply 1 minus 4. 1 minus 4, so -3. A12. So here is the element A12. So I delete the row and the column it contains. Cross multiply 2 into 1 is 2 minus -4. So it's going to be 2 minus -4, which is going to be 6. Oh, of course, this second element is supposed to be minus. So I have a negative sign outside. So it is -6. And then A13 will be plus of, that's A13, delete the row and the column it contains. Cross multiply -4 minus 2. -4 minus 2, which is -6. A21 will be plus of, A22 will be minus of, A23 will be plus of. Oh no, I must have made a mistake. Yeah, I did make a mistake. So it's, let me do it again. So that is 3-1, this is 3-2, and that is 3-3. Okay, so it always goes like plus, minus, plus. Now minus, plus, minus, plus, minus, and plus. You can verify like this. Diagonally, that's all plus. Diagonally, that's all plus. And the remaining are negative. That's a kind of checking. So I have minus here, I have plus here, I have minus, then plus, minus, and plus. Now let's evaluate the cofactors. A21, this is the element A21. Delete the row and the column it contains. Cross multiply. So when I cross multiply, -2, -4. -2, -4. So that works out to 6. A22, that's the element A22. Delete the row and the column it contains. Cross multiply. So -1, minus -4. -1, -1, -4. That's going to be 3. And A23, that's the element A23. Delete the row and the column it contains. Cross multiply. So you'll get 2 minus -4. 2 minus -4. That's going to be -6. A31, that's the element. Delete the row and the column it contains. You cross multiply. So you'll get 4 minus -2. 4 minus -2, which is 6. Then A32, A32, this is the element, delete the row and the column it contains, cross multiply 2 minus 4, 2 minus 4, it's going to be negative 6. And A33, that's the element, delete the row and the column it contains, cross multiply minus 1 minus 4, minus 1 minus 4. So that's going to be 3. I hope they are correct. And so now I can do the LHS. LHS is A times adjoint of A. I will copy my A first. A is minus 1, minus 2, minus 2. 2, 1, negative 2. 2, negative 2, 1. Into adjoint of A. Now what is adjoint? Adjoint is the transpose of the cofactor. So I will read each row but copy as the column. It's the transpose of the cofactor. So that's going to be negative 3, negative 6 and negative 6. The first row I copied as the first column. Now the second row 6, 3, minus 6, and the third row as the third column 6, minus 6 and 3. Then we multiply the two. So when you multiply, it's 3 by 3 matrix multiplied by another 3 by 3 matrix. It's going to be a 3 by 3 matrix. The row goes with the column. So just to remind myself, that's the order in which it goes. Okay, first row with the first column. So corresponding elements will get multiplied. Minus 1 into minus 3, which is going to be 3 plus. Then minus 2 into minus 6, which is 12 plus. Then again minus 2 into minus 6, which is plus 12. That's first row into the first column. Then first row into the second column. That's the first row with the second column. You multiply like that, and the corresponding elements will multiply. Minus 1 into 6, minus 2 into 3, and minus 2 into minus 6, like that. Corresponding elements. So I'm going to do that. So that will give me minus 6, and plus 12. And then third row, third column. So first row into third column. I should multiply like that, which means minus 1 into 6, minus 2 into minus 6, and minus 2 into 3. Add them up, yeah? So it's going to be minus 6 plus 12 and minus 6. Second row. So when you do the second row, it is second row into the first column. That's the second row multiplied with the first column. So that will be minus 6 plus 12. That's 12 plus 3 plus 12. And the next is second row into the third column will give me 12 minus 6 and minus 6. Then I have finally the third row into the first column, third row into the second column, and third row into the third column. So third row into the first column is minus 6 plus 12 and minus 6. 12 minus 6 and minus 6. I have 12 plus 12 plus 3. This, when I try to simplify, I get 27, 0 and 0, 0, 27, 0, 0, 0, 27. I can take a 27 out, and if I take a 27 out, I get 1, 0, 0, 0, 1, 0, 0, 0, 1. And I realized that 27 is actually my determinant A. Yeah, we did it before. That's my determinant A, 27, and the rest is I. So this becomes 27I. In fact, that was the RHS. So we got the RHS. So directly we got the answer. We didn't have to do that separately. So LHS equals RHS and it is verified. Yeah? Okay. If you need more time, pause the video, do it yourself and see whether you are getting the same answer. 31, if A is equal to a 2 by 2 matrix, 2 minus 1 minus 1, 2, and I is an identity matrix of order 2, Then show that A squared is equal to that, and hence find A inverse. Okay, so let's find out A squared. Oh, that's directly my LHS, so why not finish it off that way, LHS. So LHS is A squared, which is equal to 2 minus 1 minus 1 2 into 2 minus 1 minus 1 2. A squared is not squaring of individual elements of A. A squared is A multiplied by A itself. So I copy my A 2 times and multiply the first row with the first column. So that's going to be 2 into 2, 4 plus 1. Then first row into the second column. So that's going to be minus 2 minus 2. Second row into the first column. So that's going to be minus 2 minus 2. Now second row into the second column. That will give me 1 plus 4. So that's going to be 5 minus 4 minus 4 and 5. That's the LHS A square. Now we need to do the RHS and get the same answer. 4A minus 3I. So 4 times A, 2 minus 1 minus 1, 2 minus 3 times I, 1 0 0 1. So that's going to be 8 minus 4 minus 4 and 8 minus 3 0 0 3. I opened the bracket with 3. Now I subtract the corresponding elements. So that will give me 5 minus 4 minus 4 and 5. So LHS equals RHS. Now for the second part, they said hence find A inverse, which means making use of the earlier result, you find A inverse. So I'm going to copy my earlier result. What's my earlier result? A squared is equal to 4A minus 3I. That's my earlier result. And I want to find out A inverse out of it. Just multiply throughout by A inverse. So we say multiply each term by A inverse. So if I multiply each term by A inverse, this is A squared. And if I multiply by A inverse there, 1A gets cancelled. Because A into A inverse will become I. So A into I will be A then. So that's the logic. You could just, for convenience, consider it as they are cancelling, So 1A gets cancelled from A square because you are multiplying by A inverse. So that's A on the left side. On the right side, 4 into A. But I am multiplying it by A inverse. So A into A inverse. This is A and I multiply by A inverse. So A into A inverse will make it I. They get cancelled. It becomes I. A into A inverse is I. Minus 3 into, this is I. And I multiply by A inverse. I is like 1. Identity matrix. It doesn't make any change. So I into A inverse is going to be A inverse. And now my question is to solve for A inverse. So I'm going to rearrange for A inverse. So when I rearrange, what I do is I'll bring this minus 3A inverse to the left side and A to the other side. So that will be 3 times A inverse is equal to 4I minus A. That is 4 times I, 1 0 0 1 minus A. A means the original question. 2 minus 1 and 2. We try to simplify, take 4 inside, 4 0 0 4 minus 2 minus 1 and 2. And you subtract the corresponding elements, you'll get 2, 1, 1 and 2. That's 3 times A inverse, therefore A inverse will be divide by 3. Shift 3 to the other side. So 1 by 3 into 2, 1, 1, 2. Maybe you can even take 1 by 3 inside, so it will look like 2 by 3, 1 by 3, 1 by 3 and 2 by 3. Divided every single element by 3. 32 is to find out the inverse of a matrix A. I'm not going to do this question because you know how you do this. We repeatedly did this. In the first question, it was part of it. You find out determinant A, then you find the cofactors of individual elements, and then 1 by determinant A into adjoint of A. Adjoint of A is the transpose of the cofactor. All right, so this is a verification question. There are two matrices given to you, A and B, and the question is to verify AB, the whole inverse, is equal to B inverse into A inverse. So I need to do the LHS, I need to do the RHS and show that both are equal. So I'm going to do the LHS of it. LHS is AB, the whole inverse. Oh, hold on. If I want to do AB, the whole inverse, don't I need AB first? So I'm going to do AB first. A into B. A into B is 2, 3, 1 minus 4 into B. 1 minus 2 minus 1 and 3. And you multiply them. So when you multiply, the row multiplies with the column like that. Row goes with the column. So let's multiply. So it's going to be 2 into 1 is 2 minus 3. The next one is minus 4 plus 9. Second row. 1 into 1 is 1, minus 4 into minus 1 is plus 4. Then I have minus 2 and minus 12. So that's going to be minus 1, 5, 5, and minus 14. That's my AB. So now I can work out the LHS. LHS is AB the whole inverse. To do AB the whole inverse, the formula is 1 by determinant AB into adjoint of AB. 1 by determinant AB into adjoint of AB. So I will need determinant of AB. Determinant of AB means determinant of minus 1, 5, 5 and minus 14. Cross multiply, get 14 minus 25, which is minus 11, negative 11. So I'm going to put that back into this. So it's going to be 1 by minus 11, yeah, into adjoint of AB. Now what is adjoint of AB? I know AB. I need to find out the adjoint of AB. Need to find out the adjoint of AB and write it here. But to find the adjoint of AB, for a 2 by 2, we have a shortcut. Interchange the diagonal elements. Okay, let's interchange the diagonal elements, minus 14 and minus 1. Then make the other elements with opposite sign. So it's going to be negative 5 and negative 5. That's your answer, or maybe you can take a minus sign out since there is a minus sign common, or you can divide every element by minus element. It's all up to you. Maybe I can come back to this and then modify after looking at the right hand side. But the right hand side is going to be a bit more longer because you need to find out B inverse first. To do B inverse, this is for the right hand side. I call it as part 2 of my question. I will need determinant B first if I want B inverse. So I copy determinant B, I calculate determinant B, 1 minus 2 minus 1, 3. Cross multiply, that is 3 minus 2, which is 1. Then I need B inverse, B adjoint of B, adjoint of B. Adjoint of B will be, interchange the diagonal elements. 1 and 3 become 3 and 1. The other two elements, you make it positive 1 and 2. Okay, that's adjoint of B. Therefore, finally, my B inverse is 1 by determinant of B into adjoint of B. 1 by 1 into adjoint of B is 3, 2, 1, 1. So I have my B inverse ready with me. Now I need A inverse also the same way, and then I multiply them. That's the RHS. And then it should match with the left hand side. Yeah. So determinant of A, because I'm trying to find out A inverse, I need the determinant A. Determinant 2, 3, 1, negative 4. Cross multiply, get negative 8 minus 3, which is minus 11. So A inverse will be 1 by determinant A into adjoint of A, which is 1 by minus 11 into adjoint of A. Adjoint is interchange the diagonal elements and make the other elements negative. Yeah, I did it. So now finally I have the RHS, which is B inverse into A inverse. So I will copy my B inverse, which is 3, 2, 1, 1 into A inverse is minus 1 by 11 into minus 4 minus 3 minus 1 and 2. And I try to multiply. The row goes with the column. Yeah, of course, I'll keep that minus 1 by 11 outside. So when you multiply minus 12, 3 into 4, minus 12 minus 2, then minus 9 plus 4, minus 4 minus 1, minus 3 plus 2. So that's going to be minus 1 by 11 into minus 14, minus 5, minus 5, and minus 1. Yep, you can see that LHS is equal to the RHS. LHS is equal to RHS, hence verified. Okay, 34. There is a matrix A given to you. Cos alpha minus sin alpha 0, sin alpha cos alpha 0, 0, 0, 1. Find adjoint of A. So the first part of the question is to find out adjoint of A. We know it's going to be a bit long, and verify another result which involves determinant A as well. So I'm going to find determinant A and keep first. Then I'll go for all the cofactors and write adjoint of A. Then I will have only the verification part left. So it's pretty long going to be 2016 question. Yeah. So I'm going to first find out determinant A. Okay, let me find determinant A. So determinant A is determinant cos alpha minus sin alpha 0, sin alpha cos alpha and 0, 0, 0 and 1. Determinant A, and I'm going to expand it. So when I expand, it's going to be cos alpha into its minor. So I need to find out the minor. So minor will be cross multiply. Yeah. So cos alpha, when you say cos alpha into this minus this, so that's going to be cos alpha minus 0. The next sign is minus, and pick up the element. The element, second element is negative sin alpha. So minus is going to be plus now. Plus sin alpha into its minor. What's the minor of minus sin alpha? Delete the row and the column, cross multiply sin alpha minus 0. So that will be sin alpha minus 0. And then plus 0 into anything is 0. So I don't do anything with that. That's going to be cos square alpha plus sin square alpha, which is 1. Oh, good. That's determinant A. Determinant A is 1. Okay. Now to verify this, now the actual first question, find adjoint of A. So I need the cofactors to be calculated. So A11, these are going to be long. Okay, A12 and then A13, A21, A22, A23, A31, A32, and A33. Plus, minus, plus, minus, plus, minus, plus, minus, and plus. Okay, so I'm going to evaluate it. A11, that's the element. Delete the row and the column. Cross multiply cos alpha minus 0 is cos alpha. So I'm directly writing it. It's going to be just cos alpha. So this is just cos alpha. And for the next element, this is the element. Delete the row and the column. Cross multiply. So when I cross multiply, sin alpha minus 0. So it's just sin alpha there. And for A13, that's the element. Delete the row and the column it contains. Cross multiply. Oh, that's 0 minus 0, 0. Oh, it's not that difficult. It works out quite simple. Now for the next element, A21, that's the element, delete the row and the column it contains, cross multiply. So you get minus sine alpha minus 0. That's minus sine alpha. So already there is a minus sign. We'll make it plus. A21, that's the element, delete the row and the column it contains, cross multiply cos alpha minus 0. So that's going to be cos alpha. Then A23, that's the element, delete the row and the column it contains, cross multiply, you will get 0 minus 0. So that's going to be completely 0 there. Then A0, this one, A31, that's the element, delete the row and the column, 0 minus 0. Oh, pretty simple. And then the next element, that's out here, delete the row and the column it contains, cross multiply 0 minus 0, again 0. And final element here, delete the row and the column it contains. When I cross multiply, I'll get cos square alpha minus is plus, cos square alpha plus sine square alpha. That's going to be 1. Do you get that? So this is the element, delete the row and the column it contains, cross multiply, don't I get cos square alpha? So in this place, I'll be getting cos square alpha minus, then minus, like that when I cross multiply, minus cos square alpha minus sine square alpha, which makes it cos square alpha plus sine square alpha, which is 1. That's what I wrote there. Okay, A33 is 1. So I have all the cofactors done, so I can write the adjoint of A. So the adjoint of A, therefore adjoint of A will be the transpose of the cofactor. Read the row, write as the column. Read the first row and write as the column. Cos alpha minus sine alpha 0 minus sine alpha. No, it's not minus sine alpha. It is plus sine alpha. Sine alpha, cos alpha and 0. Then 0, 0 and 1. That's adjoint of A. Now, what's your question? It's a verification question, so I need to do, there are 3 parts. I need to do A into adjoint of A, then I need to do adjoint of A into A, then I should do determinant A into I3 and show that all of them give me the same answer. Let me do A into adjoint of A. So the first one there is A into, there are 3 things to be done here. So I'll call it as 1. A times adjoint of A. It's a verification question. Do all the 3 separately and show that they are all same. So I'm going to copy my A and multiply by the adjoint. Then do the other way around. So cos alpha minus sine alpha. You just have to have the patience to sit and do this. It's not difficult. Cos alpha 0, 0 and 1 into adjoint. The adjoint is cos alpha sine alpha 0 minus sine alpha cos alpha and 0, 0, 0, 1. Let's multiply this, and when you multiply, you will multiply row with the column. Row with the column. The first row goes with the first column. And let's see what it gives. So when I multiply cos alpha into cos alpha, cos square alpha minus into minus is plus sine square alpha, cos square alpha plus sine square alpha. First row with the second column. So when I multiply the first row with the second column, cos alpha into sine alpha plus minus sine alpha into cos alpha. So what do I get? Sine alpha cos alpha minus sine alpha cos alpha. And the last one, when I multiply like that, cos alpha into 0, sine alpha into 0, 0 into 1. So that's all 0. Second row. Second row, oh, by the way, this will get cancelled and give me 0 as well. And this will become 1. Oh, it's going to be pretty simple now. So now the second row into the first column. That will give me sine alpha into cos alpha minus sine alpha into cos alpha. So can we directly write 0 there? Do you understand that? The second row with the first column. When I multiply sin alpha into cos alpha, that's sin alpha cos alpha. Then cos alpha into minus sin alpha, that's minus sin alpha cos alpha. So sin alpha cos alpha minus sin alpha cos alpha is 0. Then the second row into this second column, that will give me sin square alpha plus cos square alpha plus 0. So that's going to be 1. Sin square alpha plus cos square alpha is 1. Then this second row into the third column, when I multiply sin alpha into 0 is 0, cos alpha into 0 is 0, and sin alpha into 0 is 0, cos alpha into 0 is 0, and 0 into 1 is 0. Every single element is 0, so the total is 0. Now the third row, when I multiply, that's the easiest. 0 into cos alpha 0, 0 into minus sin alpha is 0, 1 into 0 is 0. So that element is 0. The next one, when I take 0 into sin alpha is 0, 0 into cos alpha is 0, 1 into 0 is 0. So that's going to be 0 here. And when I take the next one, 0 into 0 is 0, 0 into 0 is 0, 1 into 1 is 1. So this is basically 1, 0, 0, 0, 1, 0, 0, 0, 1. Which is actually I. This is I. Can I write I as 1 time I? No harm, right? 1 time I, yeah. And what is 1? 1 is actually determinant A. So determinant A into I3. I, identity matrix of order 3. So determinant A into I3 I can write, which means I already proved that A into adjoint of A is equal to determinant A into I3. I'm sure you can do adjoint of A into A exactly the same way. So the second part of it, instead of A into adjoint of A, you put it the other way around and multiply. Okay. So you'll be doing exactly the same way. Just quickly 2 more word problems and then we are done. Okay. Question 35, it says the monthly incomes of Aryan and Baban are in the ratio 3:4. So I'm going to write that information. Aryan's income, monthly income. Aryan's income is 3x. Baban's income will be 4x because it's in the ratio 3:4. What do they say? And their monthly expenditure, the monthly expenditure is in the ratio 5:7. So Aryan's expenditure 5y, because 5:7. So I'm going to take it as 5y and 7y. Baban's expenditure is 7y because the expenditures are in the ratio 5:7. So we know how much is Aryan's income 3x and how much is Aryan's expenditure 5y. So from 3x income he spent 5y. From 3x rupees which he gets, he spends 5y rupees. So how much is left with him? And that is going to be his saving. So 3x minus 5y will be his saving. And what do they say? Each of them saves 15,000 rupees per month. So we are going to say 3x minus 5y is equal to 15,000. Now again, what do they say? Baban. Baban also saves 15,000. How much is Baban's income? 4x rupees is what he gets. 7y rupees he spends. So what is remaining with him is 4x minus 7y is equal to 15,000. So the question says solve this by matrix method. Yeah, so we convert it into a matrix form. It's 3 minus 5, 4 minus 7 into xy is equal to 15,000, 15,000, which we call as Ax is equal to B. Therefore, x is equal to A inverse into B, equation number 1. So I just have to calculate my A inverse now. And to find out A inverse, I know there are two steps. First step is to find out determinant A, which is determinant 3 minus 5, 4 minus 7, cross multiply minus 21 minus 20, which is minus 21 plus 20, which is minus 1. Determinant A is minus 1. Now I need adjoint of A. Adjoint of A has a shortcut. Adjoint of A has a shortcut for a 2 by 2 only. So shortcut is interchange the diagonal elements. 3 and negative 7 will become negative 7 and 3. Make the other elements with opposite sign. So positive 4 becomes negative 4 and negative 5 becomes positive 5. So I can find what is A inverse. Therefore, A inverse is 1 by determinant A into adjoint of A, which is 1 by determinant A. 1 by determinant A is minus 1 into adjoint of A is negative 7, 5, minus 4 and 3. Since it is just a minus sign outside, I want to take it inside. If it was any other number, I would have left it as fraction like that only. It's easier. So 7 minus 5, 4 and minus 3. That's my A inverse. So I can now go back to equation number 1. Equation number 1 becomes x is equal to A inverse into B. X means x and y. So equal to A inverse is 7 minus 5, 4 minus 3 into B. B is the right hand side matrix, which is 15,000, 15,000. Multiply, get the answer. So 7 times 15,000. Oh, that's a shortcut actually. Why multiply by 15,000? There is 15,000 common factor in the second matrix. So why not take it out? So it's going to be 15,000 common factor from the second matrix. So what is left here is 7 minus 5, 4 minus 3. You can take anything out like that only if it's common factor for every single element. And here it is in the second matrix. So I took it out. So my multiplication becomes easier. So 15,000 into row goes with the column. So that's going to be 7 into 1 plus minus 5 into 1. Next row, 4 plus minus 3. So that will give me 15,000 into 2 and 1. So that will give me 30,000 and 15,000. Therefore, x is 30,000 and y is 15,000. What's our question actually? Find their monthly incomes using this method. To find the monthly income, I am not even interested in I want only the x value. I'm not even interested in the y value. Your question is to find out their monthly income. We said the monthly incomes are 3x. So 3 into, how much is x? We found x as 30,000. So 3 into 30,000, which is 90,000. And y is 4 into 30,000, which is 120,000. So that's income rupees, of course. Yeah, that's their income. Yeah. So we'll continue with this in the next video for more revision questions. Okay.